Bismillahirrahmanirrahim. Assalamu alaikum. I am Sabir Ali. Now we are going to start a playlist about electricity and magnetism. In this playlist, we hardly try to see beyond the equations. Did not mean about its history, but a better understanding. And trust me, it's very beautiful. Electricity and magnetism are all around us, such as electric bulb, electric clock, microphone, television, VCR, calculator, etc. Light itself, the electromagnetism phenomena. Our cars, trains, planes can only run due to electricity. Even we cannot see without electricity. We cannot think without electricity. We cannot walk without electricity. Even our heart cannot beat without electricity. When we want to define electricity and magnetism in few sentences, then we state as: electricity is the presence flow of charges, and magnetism, property of metal, pull closer or repel each other. In its earlier stage, these both considered separate to each other, but with the development of Maxwell equation, these both combine. When we combine the statement of electricity and magnetism, then we get electromagnetism. The movement of electric charges is an electron produce magnetic field. We know in electric cables there are freely moved electrons, and then they flow through this conductor, then they produce magnetic field. We see electric cables has a cover of insulator. It is due to safety. When charges flow through this conductor, they produce magnetic field, and without this insulated cover, these charges due to magnetic field can harm any person and body. Now we further move to electric charge. Electricity is derived from electron, it's Greek word. And when we want to define the electric charge in few sentences, then we can say as the property of metal that causes it to experience a force when placed in magnetic field. When we brought a charge near the magnetic field, it will experience the force. Does not matter this force of repulsion or force of attraction, it will experience a force. Benjamin Franklin was the first person who gave the name of positive and negative to these charges. He was the man who first time gave us the idea of positive charge and negative charge. When we have two positive charges or two negative charges, mean like charges, and brought near to each other, they repel each other. It means that like charges repel each other, and when we have a positive charge or negative charge and brought close to each other, they attract each other. So mean unlike charges attract each other. In recommended book, we have some examples of positive and negative charges. In these examples, we have 4 rods, 2 plastic rods or 2 glass rods. When we rub plastic rod with fur, they get charged, they get negative charge. And when we brought close to each other, they repel each other. And on the other hand, we have rod of glass and fur with silk. And when we brought both to each other, they become same like but have positive charge. And when we have a plastic rod with negative charge and a glass rod with positive charge and brought close to each other, they will attract each other. It's due to unlike charges. The resistance can produce charges, as we experience in our daily life. When we get off the shirt, especially of nylon, then we feel a spark to our body. And when we walk to a carpet, our shoes rub with the carpet, and when we press the doorknob, we feel some jerk. And when we comb our hair, we feel some spark. It's all due to charges. Here we have a structure of atom. The proton and neutron lie at nucleus, and 99% mass of an atom depend its center in nucleus, and electron move around the nucleus. And what happened with the charges when a charged body brought near a conductor? Here we have an example of conductor. Its conductor and the black body positively charged brought near the conductor. We know there are freely moved electrons in conductor. When we brought a positively charged body near the conductor, then the negative and positive charge arranged in a specific pattern, and due to this positive charge, the negative charge will get near the positive charge due to force of attraction. These positive will repel to each other, but the distance is large than the positive and negative charge, so they will be attract to each other. And what happened when we brought a charged body near the non-conductor? In non-conductor there are not freely moved electrons. So what happened? Here is an atom of non-conductor, and this is positively charged body. When we brought near to this atom, then the electron, due to negative charge, will be attracted to this positively charged body and will move in this shape. Here we have positive charged body the electron will be attracted by this charge point. So the orbit of an electron is like this shape. Here we have an example in recommended book how the laser printer work. In first step, wire spray ions on the drum a positive charge. This is drum. Wire charged it as a whole positively charged. In second step, laser beam right on the drum leaving negative charge area where image will be. In the third step, rulers apply positive charge toner to the drum. Where is toner? Which have ink, and this is drum. Negative charge shows that the printing will be here on negative charges, not on positive charge. So the toner will spray the ink to negative charge. Okay, now move to fourth point. Fuser laser heat paper permanently attached. This is paper, and when it will get out to the printer, then the fuser laser heat the paper. So the ink permanently attached to the paper. And in fifth step, where is fifth step? This one. This is discharge lamp, and when our page get out after printing, then the discharge lamp discharge this drum as a neutral. That's all for today. I hope you understand this topic, and now I think I should go. So see you to the next video, and for now, Khuda Hafiz.